Hello students, welcome you all to the video lecture on flag register in 8086. So first of all, flag register in 8086, it is a 16-bit register and it contains both status as well as the control flags. So totally it is having 9 active flags. So flag is one which can be either set or reset. It is a 1 bit which can be either set or reset according to the arithmetic and logical operation, and also it is used to control the execution of the processor. So under the status flag we have 6 flags, that is carry flag, parity, auxiliary carry, zero flag, sign flag and overflow flag. So generally whenever we do arithmetic operations like addition, we may get a carry. So in that case carry flag will be set. Similarly during the subtraction operation, we used to get the borrow. So in that case also carry flag will be set to 1. And the next flag is parity flag whenever the result has even number of ones. For example, if I have the value like this, how many number of ones are there? 4. So 4 is nothing but even number. So in this case I can say that parity PF is equal to 1. So suppose if I have this bit also 1, then how many number of ones are there? 5. So 5 means odd number. In that case, so 5 is odd. So in that case PF is equal to 0. So like that, if the result contains even number of ones, I can say PF is equal to 1. If the result contains odd number of ones, then I can say that PF is equal to 0. And then auxiliary carry flag. So whenever we are doing some operation, if we have a carry from bit 3 to bit 4, that is lower nibble to upper nibble, then AF is equal to 1. So let us see one example for each and everything. And then zero flag. Whenever the result is a 0, then zero flag is equal to 1. When result is a 0, I can say zero flag is equal to 1. When result is not 0, then ZF is equal to 0. Sign flag. When result is negative, SF is equal to 1. When result is positive, SF equal to 0. And then whenever there is a overflow occurs, that is this happens whenever there is a signed numbers. For example, when we have 8-bit numbers, I can say the signed numbers will range from minus 128 to plus 127, right? So in those cases, if it is a 8-bit data, that is we have D7, D6 up to D0. So whenever there is a carry from D6th bit to D7th bit, then overflow flag is equal to 1. That is, we should get a carry from D6 to D7 as 1, and there should not be any carry from D7th bit. That is, carry from D7th bit, it should be 0. Then only my overflow flag is equal to 1. So if we consider 16-bit data, then the range of the number is from minus 32768 up to plus 32767. So in that case, we have from D15, D14 and so on up to D0. So here I can say that whenever I have a carry from D14 to D15 bit, that is 1, carry 1 from D14 to D15 bit, and there is no carry from D15th bit, that is here the carry should be 0. So whenever there is a carry from D14 to D15th bit as 1 and there is no carry from D15th bit, then I can say that overflow flag is equal to 1. So you should have a carry from D6 to D7 and no carry from D7th bit if it is 8-bit data. If it is 16-bit data, you should have a carry from D14 to D15 and no carry from D15th bit. Then I can say that overflow flag is equal to 1. And then coming to the carry flag, so carry flag again, if it is a 8-bit data, I should get a carry from D7th bit. So for the carry flag, Again, if it is 8-bit data, I have D7 to D0. I should have a carry from D7th bit. I should have a carry from D7th bit. Then I can say carry flag is equal to 1. If it is a 16-bit data, I have D15 to D0, right? So in that case, I should get a carry from D15th bit. That is, in both 8-bit data and 16-bit data, I should get a carry from MSB bit as 1. So here from D7th bit I should get 1. Here D15th bit I should have a carry as 1. If it is so, I can say carry flag is equal to 1. So similarly again, if it is the addition, I will be having the carry from MSB. If it is a subtraction, it may be a borrow. So borrow may be into the D7th bit. Similarly, borrow may be into the D15th bit. In both the cases, carry flag is equal to 1. So let us see these status flags by using a example so that you can easily understand. So if you have the instruction move ax comma ff ff, add ax comma 0001. So what happens here? We are moving this value. This is immediate data. Immediate data is moved to AX register. So AX value is FF. And then after that what you are doing? Adding. So what this instruction will do? It will add AX plus 0001 and then result will be stored in your AX. Okay. So I am going to check the status of your flags after this addition operation. So first let us see the addition. So we have to add this AX value with the 1. What is AX? FF. So AX value is FF. Just write in the binary manner. So how will you write FF 111 111 111 again 111. What about 0001? Because we have to add that value. 0 means 0000, again 0000, again 0000, 1 means 0001. So these two numbers we are adding since it is addition operation. So 1 plus 1 it is 10. So you have 0 and then carry 1. Again 1 plus 1 it is 10, 1. So again 1 plus 1 it is 10. So again 1 plus 1 it is 10. The same thing happens. 1 plus 1 10, 1 plus 1 10, 1 plus 1 10, 1 plus 1 10, that is 1 0, again 1 plus 1 10. So like this happens, right? So 1 plus 1 10, finally I am getting a carry out of this numbers, right? So now we have this bit is D0, D1, D2, D3 up to D15 we have. So let us now check the result, right? This is your result which is stored in your AX. So we have all the values as 0. So AX value is what? Just 0. So what is the value now? AX value is 0. So whenever my result is 0, Z flag is set to 1. Okay. Whenever the result is 0, zero flag is equal to 1. Okay. And then check how many number of ones are there. So here there is no ones at all. So there is no ones at all means number of ones it is 0. So again number of ones it is 0 means 0 is a even number. Okay, there is no 1 at all. So by default this number is a even number. So whenever it is even number, parity flag is equal to 1. So when you have 0 ones also, 2 ones, 4 ones in your result, I can say that it is even number. So here the parity flag is equal to 1. And then what about your auxiliary carry flag? Auxiliary carry flag means whenever you have a carry from D3rd bit to D4th bit. So here what happens, 1 plus 1 is 10. Here 0 and you are having a carry from D third bit to D fourth bit. That is, these 4 bits are nibble. Lower nibble to upper nibble, you are having a carry. So I can say that again auxiliary carry flag is also 1. And then when you see the MSB of the result, MSB is what? D15th bit. So for the sign flag, we have to see the D15th bit, that is MSB bit. So this bit, if it is a 0, D15th bit, if it is 0, sign flag is 0. Whenever this bit is 1, sign flag is 1. So here D15th bit, that is most significant bit, is equal to 0. So sign flag, it is 0. So sign flag, it is 0. So next we see about the carry flag. So carry flag means we have to get a carry from D15th bit. So here when we see again the addition operation, so here when we see the D14th bit, 1 plus 1 is a 10, here 0 and then again 1 we are getting, and then again 1 plus 1 it is a 10, so we are getting a 0 and then we are getting a carry. So here we are getting the carry from D15th bit as 1. So since we are getting the carry from MSB bit, I can say that carry flag is equal to 1. Suppose if we are not getting the carry from D15th bit, then CF is equal to 0. But here in this problem, we are getting the carry from D15th bit, so CF is equal to 1. And then the next flag, it is overflow flag. So what is the condition for overflow flag? Here when you have the carry from D14th bit to D15th bit and there is no carry from D15th bit, then only overflow flag will be 0. So when we check here, so here 1 and 0 we have. So previously from the D13th bit we are getting one carry here, right? So this 1 plus 1, this 1 plus 1, it becomes 10. So 0 and we are getting the carry here. So we are getting the carry from D14th bit to D15th bit as 1, as well as from the D15th bit we are getting the carry as 1. So D14 to D15 also we are getting one carry, and from D15 also we are getting carry. So what is the condition for overflow? We should get the carry here, but here we should not get any carry. But since we get carry in both the cases, here overflow flag it is 0. Overflow flag it is 0. Overflow flag will set only when this bit is 1 and this bit is a 0. But here in this case it is not so. In both the case, that is D14 to D15 as well as from D15 we are getting the carry. So overflow flag is equal to 0 here. So for this problem, ZF is equal to 1, parity flag is equal to 1, auxiliary carry is 1, sign flag it is 0, overflow flag is 0 and carry flag it is equal to 1. And now let us see about the control flags. So we have 3 control flags. So from the definition itself, trap flag is what? It will execute the instruction one at a time for debugging. So it is useful for debugging. So whenever TF is equal to 1, the 8086 will execute one instruction and it will show the result to the programmer. And then again it will execute the next instruction and it will display the result for the programmer. So particularly when there is an error, then it is useful for the programmer to detect the error by seeing the result after execution of the instruction one by one. So suppose if we have 2 instruction, right? So suppose if we are giving this 2 instruction in a 8086 and we are making trap flag is equal to 0, these 2 instruction will be executed and then we will get the result. But if we make TF is equal to 1, first this instruction will be executed and result will be shown to the programmer, and then again next instruction will be executed and again result will be displayed, so that If there is any error in the instruction, it is easy for us to correct that particular instruction. So mainly it is useful for debugging. And then interrupt flag. So interrupt flag means it can either enable or disable the maskable interrupt. That is, in 8086 we have one pin called INTR. So using the INTR, the peripheral interrupts will interface the 8086. So from the peripherals we can get the interrupt. We can get the interrupt through this pin INTR. So whenever we are getting the interrupt from the peripheral devices, then again what your 8086 will do means it will check your IF flag. So whenever IF is equal to 1, then only it will accept the interrupt and it will execute that interrupt. If IF is equal to 0, then it will ignore that particular interrupt. So when IF is equal to 1, it will accept the interrupt. When IF is equal to 0, it ignore the interrupt. So for example, whenever you are doing some work in the laptop, suppose if you are getting the message in the WhatsApp, that is nothing but your interrupt. So what you people will do, either you will check that WhatsApp or you will ignore. So if you are ready to accept the interrupt, then you will read that message. If you are not ready to accept the interrupt, you will ignore, right? You will ignore that interrupt. So like that, if it is IF is equal to 1, then the maskable interrupt coming through the INTR will be accepted. If IF is equal to 0, then that particular interrupt will be ignored. It will not disturb your operation. Then the direction flag under your control flags. So the direction flag, according to the statement, again DF is equal to 0 means the string operations will be proceeded from lower address to higher address. If DF is equal to 1, then it will consider the string from higher address to lower address. So particularly your direction flag is very useful in the string operations. So for example, if I have a string and my address is 2000 and 2001 and 2002, so I have the value as A, B, C. Okay, so if DF is equal to 0, first it will take this value, that is it will take the string as A, first character of a string as A, and then it will move to the next address, then the next character will be considered, and then it will move to the next address and next character will be considered. That is what your direction flag DF is equal to 0 will do. So it will move on from lower address to upper address. Suppose if DF is equal to 1, then it will start from higher address. So first it will take your C from 2002 and then the next lower address, that is B, and then the next lower address, that is A. Like that it will proceed from higher address to lower address for the string operation if DF is equal to 1. We can, in another way I can say that this is auto increment. So automatically it will increment from lower address to upper address. This is auto decrement. It will decrement from higher address to lower address. Particularly DF is useful for string operations. So thanks for watching.